Hello everyone. So today I, Swati Verma, Assistant Professor at Calcutta University, School of Medical and Allied Sciences, shall be discussing with you about types of spectroscopic technique. So in the previous lecture we have discussed about the basic of spectroscopic techniques, what is a spectroscopy and what are the different types of electromagnetic radiation we have. Now moving forward, we will discuss about the different types of spectroscopic techniques on the basis of the three principles that we have discussed, that is the absorption of electromagnetic radiation, emission of electromagnetic radiation and the scattering of electromagnetic radiation by the sample. So, the effect of electromagnetic radiation on interaction with the matter depends upon the energy associated with the radiation. As we have discussed that each and every electromagnetic radiation has certain amount of energy, and if we want to calculate that particular amount of energy, so we can use the formula E is equals to h nu, where nu represents your frequency and frequency is equals to c upon lambda, where c is the speed of light and lambda is the wavelength. So each and every electromagnetic radiation has certain amount of energy, and the effect that that particular electromagnetic radiation will have on our matter will totally depend upon the energy of electromagnetic radiation associated with the radiation. So very energetic radiation like we have gamma rays, UV rays and X-ray region of spectrum may cause an electrons to eject from the molecule. So as we know that a gamma radiation, UV radiation, X-ray radiation have very less wavelength and are highly energetic. So as these particular radiation fall over our sample, what will happen? They can cause the ejection of an electron. So we can say that they can cause ionization. So they work at the ionic level. Radiation in the infrared region of the spectrum have less energy in comparison to your UV radiations or X-ray radiation. So these particular radiation will not produce ionization as they are less energetic. They must be able to cause vibrations in the molecule. A total energy of radiation, that is E total, is equals to your energy of translational, vibrational and your rotational energy. So our highly energetic radiation can produce changes in overall energy of the radiation as they are highly energetic. Less energetic radiations like your IR radiation can only produce vibrations in the molecule. Your or much less radiation like we have microwave radiation. These are even less energetic in comparison to your IR radiation, so they are unable to produce vibrations even. So they can neither produce electronic transitions in the molecule nor they can produce vibrations in the molecules. What they can do, their energy is just sufficient to cause rotations in the molecule. So highly energetic radiations can cause ionization here, and radiations which are less energetic in comparison to your UV radiations can produce vibrations in the molecules. Here even less energetic radiations like we are having microwave radiations can only cause molecules to rotate. So here we have mentioned the region of spectrum and the type of electronic transition. So first is we are having your ultraviolet visible region. So in case of ultraviolet visible region, as I have already discussed, that this particular ultraviolet region is able to cause ionizations in the molecules as these are highly energetic radiations. So it can cause electronic transition. Your IR radiations are less energetic, they can produce molecular vibrations. Your microwave radiations are even more less energetic, so they can produce molecular rotations. So radio waves frequencies can only cause spin in the molecule. They can only produce spin. Now that particular spin can be a nuclear spin or electronic spin. If your nucleus is spinning, then that refers to your nuclear spin. If your electron is spinning, then that refers to electronic spin. So we have different regions of the spectrum and the type of electronic transition occurring in that particular region. So we have electronic transition in case of ultraviolet visible, molecular vibration in case of infrared, molecular rotation in case of microwaves, nuclear spin or electronic spin, which refers to NMR or ESR in case of radio frequencies. Now we will talk about the types of spectroscopy. So spectroscopy is the collective term that we are using for a diverse group of techniques in which the interaction of electromagnetic radiation with the matter of interest are studied. As we have already discussed that in this particular case what will happen, a matter, as we can say here, a matter which is present in your ground state, suppose this is your matter, and we have our incoming radiation which can be referred like this. So whenever our incoming radiation interact with the matter, what will happen? There either occurs the scattering, emission or absorption of your electromagnetic radiation. So this particular three principle, that is absorption, emission or scattering by the matter, give rise to our three principal branches of spectroscopy, that is absorption spectroscopy, scattering spectroscopy and emission spectroscopy. Now we'll discuss each one by one. First we will discuss about absorption spectroscopy. What is absorption spectroscopy? So here, as its name indicates, absorption spectroscopy, so you can easily refer that in case of absorption spectroscopy, what must be happening? The absorption of electromagnetic radiation. So absorption spectroscopy studies radiation which is absorbed at different wavelengths. So what will happen? Your incoming radiation, your incoming electromagnetic radiation is absorbed by your matter. Now when a beam of electromagnetic radiation will pass through a sample, much of the radiation will passes through the sample without a loss in intensity. That is, whenever we will pass a particular electromagnetic radiation towards a sample, so much of the radiation will pass through the sample as it is. There occurs no loss in the intensity of radiation. If the intensity of our incoming radiation is 100%, then much of the radiation that will pass through the sample is of that particular 100% intensity. But at selected wavelengths, what will happen? You will observe the decrease in the intensity of radiation. So however, the radiation intensity is attenuated. Attenuated refers to the decrease in the intensity of radiation. So this particular decrease in the intensity of the radiation is refers to the absorption. So in absorption, what will happen? Your intensity of the incoming radiation get decreases. And what is the main reason behind that particular decrease in the intensity of radiation is the absorption of radiation by the sample. So what will happen? Whenever you will pass your electromagnetic radiation through a sample, your sample contains certain absorbing species. So what will happen? Your sample, which is present at ground state, after absorption of electromagnetic radiation, your molecules gain energy and will show a transition from the ground state to the excited state, that is electronic level transition occur. And in that particular transition, or you can say for that particular transition to occur, they requires the certain amount of energy. So that particular energy they gain from the electromagnetic radiation. So this particular process of attenuation is called absorption. Absorption spectroscopy can give both qualitative as well as quantitative information about the sample. So on the basis of this particular absorption of incoming radiation, we can perform both qualitative as well as quantitative study about the sample. In case of absorption spectroscopy, an electromagnetic radiation is absorbed by an atom or molecule which undergoes a transition from the lower energy state to a higher energy state. So upon absorption of electromagnetic radiations, your molecules which are present at your lower energy state, that is ground state, will show a transition towards your high energy state, which refers to your excited state. Now absorption only occurs when the energy of radiation matches the difference in energy between two energy levels. So we have a basic criteria, that is the energy of electromagnetic radiation must match to the energy difference. We can see here clearly that this is your molecules. Your molecules are present at your lower energy state, that is ground state. So whenever we have an incoming electromagnetic radiation, so this particular electromagnetic radiation gives energy to the molecule, and these particular molecules which are present at the ground state will show transition from your lower energy state to the higher energy state, that is from ground state to excited state. But for this particular transition to occur, what is the basic criteria? The basic criteria is that your energy of electromagnetic radiation, the energy of this particular incoming electromagnetic radiation must match with your delta E. Now what is delta E? Now delta E is the energy difference between your states. Your excited state refers by your E2, your ground state represented by E1. So delta E is the energy difference of the two states, excited state and ground state. So delta E is the minimum amount of energy which a molecule requires to show transition from the ground state to excited state. So this particular energy must be given by your incoming electromagnetic radiation so that your molecule can show transition from ground state to excited state, and this refers to absorption. Absorption, you can say that the attenuation of incoming radiation. Now the type of transition will depends on the energy of electromagnetic radiation. So on the basis of that, we can have atomic spectroscopy, which refers to the study of the electromagnetic radiation absorbed and emitted by the atoms. Second, we can have a molecular spectroscopy. Molecular spectroscopy refers to the study of electromagnetic radiation absorbed and emitted by the molecules. One more spectroscopic technique we can have, that is your ionic spectroscopy, which refers to the study of electromagnetic radiation absorbed and emitted by your ions. So on the basis of the types of matter, we can have three types of spectroscopic techniques: atomic spectroscopy, molecular spectroscopy and ionic spectroscopy. Next, in case of absorption, we get a spectrum which refers to as absorption spectrum. So what is absorption spectrum? Absorption spectrum is a plot of the light absorbed by a sample versus the wavelength of the light. So we have spectrum is basically a graph which we plot between your absorbance, that is the light absorbed by a sample, versus the wavelength of the light. So on the x-axis we have the wavelength of light, and on the y-axis we have the absorption, that is light absorbed by the molecules. Moving forward, now we will discuss about the major types of absorption spectroscopy. So on the basis here we have written the electromagnetic radiation and the spectroscopic type. So first we have spectral X-ray radiation. So that is your X-ray spectroscopy. If we have UV visible radiation, so that refers to UV visible spectroscopy. If we have IR radiation, then we have IR absorption spectroscopy. We have microwave radiation, then we have microwave absorption spectroscopy. If we are having radio wave as the incoming electromagnetic radiation, then either we can have electron spin resonance spectroscopy or nuclear spin resonance spectroscopy. So on the basis of our type of incoming electromagnetic radiation, we have different types of the spectroscopic technique if absorption is occurring. Next, this is your basic instrumentation of each and every absorption spectroscopy technique. So we have an instrument which is used to measure the absorbance by measuring the amount of light of a given wavelength that is transmitted by a sample, and that particular instrument is known as spectrophotometer. So basically, a spectrophotometer consists of a light source. This is your light source. Then we have a monochromator. So your monochromator is basically your wavelength selector. Your wavelength selector can be your monochromator, or we can have filters as our wavelength selectors. Next we have our sample holder, which is known as a cuvette, which is required to hold the sample. And last we have a detector, which can detect the radiation transmitted by a sample. So we have different types of light source depending upon the spectroscopic technique. Then we have different types of wavelength selector. Either we can have filters or we can have monochromators. In monochromators, either we can use your prism or we can have grating as a monochromator. Then we have a sample solution. Sample solution should be transparent and it is capped in a cuvette. Then we have detector. Detector is basically a transducer which will convert your photonic signal into electric current. So this particular detector can be of different types depending upon the electromagnetic radiation. Then here I have mentioned your Jablonski diagram, which is also known as energy diagram. So the process that occurs between the absorption and emission of light is usually referred by the Jablonski diagram. So this is your energy diagram. Here is your referring your different types of absorption and emission occurring by a particular molecule. Now, these are your certain references, books of references that you can refer to study these particular topics in detail. Thank you very much.